In Chapter 5, we're going to be talking about probability, basically a series of calculations you can do to determine the likelihood of some kind of event happening. We're also briefly going to discuss, depending on the situation, how the probability of events happening can be distributed in a practical setting. So for every probability that you find, you are going to have a sample space of an experiment. And I know people hear the word experiment and think about people sitting in a lab with beakers, etc. In our application, it doesn't really need to be that. It's just any way that you can break down the overall bigger picture of what you're looking at. So as an educator, my experiment space could be each individual section that I teach. In a business, it could be any one work day, work week, etc. And that sample that you have is S, and it contains all of the possible outcomes that somebody could get in your experiment. So going back to grading over here, the sample set for a letter grade system would be A's, B's, C's, D's, and F's. That's the only options that you can get. There might be some pluses or minuses in there to make the sample a little bigger, but the same concept applies. Or if you're in a course that's pass-fail, your sample is only going to have two possible returns, either a pass or a fail. And in this sample, we're going to have all of those outcomes. Some samples, the outcomes are mutually exclusive. They say you can only get one or the other, while in other samples, there'll be a possibility that you can have multiple returns from the same list of possible options. Some samples will have exhaustive events, where all possible outcomes that you can get from the experiment you're doing, from the time frame that you're analyzing, from each section of your class, however you want to label it, belong to that event. So all possibilities for it have to be in there. And all of those added together should contain the total probability. If an event is mutually exclusive, as I said before, you can't have shared outcomes. You have to get one or the other. So grading is the best way to think of that for a college student. You can't get both an A and a B in a class. It's got to be one or the other. Therefore, in that sample we had before, what was the letter grades for a class, they are mutually exclusive. You can't do both. Exhaustive means that the area of the sample that you're looking at has to add up to the entire possibility of outcomes that the sample had. So if you're going through and you're looking for only students that got an A and a B in your class, it's not going to be exhaustive because there's other possible returns within that sample set. Students get a C, D, or F. So in this instance, if you're looking at a section as an educator to figure out what percentage of your students, what the probability is a student would get an A or a B in a class, they're mutually exclusive, but they're not exhaustive because not all of your students, even though as much as we would love it, are going to get an A or a B in a class. Unfortunately, some students will get a C or less. But if it was pass-fail, well, then it is exhaustive because that's the only two options that you had. So basically every student that would be in that class has to do one of the two things. They either pass or they fail. Visually looking at this, the best way to go about it is a Venn diagram. And I'm sure you'll see plenty of these in your further studies as you go through. The entire area of the sample is the rectangle denoted as S. It's all of the possible returns that we could have here. Each individual possible return that you have is going to take up a portion of that overall sample size. So here we have outcome A and outcome B. While they are part of the sample, we can tell right here that they're not our only two possible returns because the total size of the sample is bigger than the expected probability we have of A and B. And then there will be times where you're looking for one condition or the other, or there will be other times where you're looking for both conditions to happen simultaneously. Well, if you're looking for one or the other, the way that's expressed in probability is this U-looking shape that you have over here. A or B is what this line right here designates. Now it can be both. As we see, there's a space in the middle where these two overlap, but anything where outcome A or outcome B is met is going to count for the total probability of this happening. On the opposite end of that, you have the intersection of these two events where both of them have to happen. If you're looking for the probability of A and B happening, you can't just add together A and B because there's only a certain part of your sample that's going to meet both conditions. So when you're looking for the intersection, it's going to look like this, an upside down U, A and B. And it's going to cover all possible outcomes in A and B, but you're only looking for the portion that's the overlap between the two. Another important concept to have is the complement. And in an event, we'll go back to that pass-fail grading over here, where one event that you have only takes up a certain amount of the sample space. The probability of that event not happening has to be the remainder of the sample space. So for a complement in this instance, if the probability of A occurring was defined by this red circle, the probability of A not occurring, or the complement of A, if you will, would be the entire sample space that's not occupied by that red circle. So for probability, it is typically expressed in a decimal form. I won't lie to you, I personally always think of it as percentages, but when you see it, you'll see this has a probability of 0.15, and in my brain that says that means there's a 15% chance of it happening. Universal truth, so probability, you can't have less than a 0% chance of something happening, ever. So your probability is always going to be greater than or equal to 0. And you can't have more than a 100% chance of something happening, because that means it's an absolute certainty. So your probability is going to exist in a space where you get a decimal return, if we're expressing it in decimal form, because it can't be less than 0 and it can't be greater than 1. The sum of all of your probabilities, if the events are mutually exclusive and exhaustive, have to be the entire sample set. So adding up all of the different conditions you could possibly meet, in this case, should equal up to 1, the full 100% of the sample. So going back to grading, if you added up the percent chance that a student got an A, B, C, D, or F, that's the only 5 outcomes that you had in a class, all of those better add up to 1, the entire 100% of outcomes that the class can have. So where do probabilities come from? Like, how do you determine, okay, we have this percent chance of this event happening? There's different ways you can get there. Subjective means you're drawing on personal and subjective judgment. As a managerial accountant, most probabilities that you make for how much you're going to be able to produce, what amount of revenue you're going to generate, etc., are subjective. You're looking at a bunch of things in the situation and you're analyzing all of the different events that are happening to make a prediction. If you are in a you're working for a resort and you're trying to figure out what foot traffic is going to be to at your resort during the summer, well, if the economy is bad, you can probably expect that it's not going to be as good as it would be if the economy was good. If the weather is cold and rainy, it's not going to be as good as it was hot out. So subjectively, you're looking and using your personal judgment based upon the situation you have to make an expected probability. Empirical is like cold, hard calculations. You have data about what has happened in the past, and you are just going to apply that data that you have from previous experiments, if you will, to what's going forward. So if you're looking for the probability of foot traffic at a resort, just like I was saying about here, you would look at what it was every month for the last 5 years, and based upon that, you would draw a conclusion using your empirical data. And then lastly, there are events where there is just classical probability. I like to play poker. I have for a long time. There is a very set probability that you have in poker, because the deck of cards is always the same. There's 52 cards in the deck. A quarter of them are going to be of each suit. There are 4 of each rank that you have, which means 1/13 of the deck is kings, etc. That's logical. Like, it has to be that way. So there are events that you'll have where you just know that this is the way that it's going to work out based upon the universally accepted structure, and that is a classical probability, using something that has to logically be to make predictions about what's going to happen in the future.